Welcome to another episode of StuyPulse History. This week we will be talking about our 2008 season and our robot Desbot. Joining me is Steven Lam, our 2008 President of Engineering and operator of the robot. Do you have any other robotics resume things, Steven? Were you field construction?
Oh, yes. I was the director of field construction my junior year. I was the webmaster that same year, primary machinist in 2007, vice president of engineering 2007. Yeah, and then capped it off by being president in 2008.
Hey, so you were allowed to hold multiple positions back then?
Yeah, because there weren't that many people on the team back then. And like webmaster wasn't really a position until we made it a position. So before us, before me and Nathan Keys, there wasn't really a webmaster position. But then we decided to kind of like go to the Webmaster Academy that was being hosted by New York City First. We took the class, and then we started designing the website together. And then that was actually the year we won our first website award.
Oh, cool. Yeah.
The website looked a lot worse back then. The website looks
yeah,
great
so it's
nowadays.
Yeah, like I'm on the website right now. They updated it, I think, in like 2013 or 2014. I think Justin worked on that. And it's really nice. Okay, so I actually thought instead of starting with the animation, we would start with this robot right here, which I hope looks familiar, Steven.
Yeah.
Do you want to talk a little bit about this guy? Because I talked about the 2007 season last week.
So during the 2007 season, we had design for the arm. It was actually very unique in terms of this, like, it was this clock movement arm where instead of like leveraging outwards, it leveraged sideways. So the idea was that it was supposed to help you from leaning too forward and possibly getting damaged during like operation, during competition. But it was a very different design.
I showed it last week. It wasn't the best design.
Yeah, and the guiding mechanism wasn't that great. So me and Andrew were in the Rafael Cologne's, the old robotics coach, 10 Tech class, and we had to build robots. And for the class, he said, "Oh, you actually have to design one for last year's competition." So all the students in that class got to build one, and then me and Andrew partnered up and we built this one. It's a 4-bar linkage with a pneumatic actuated grabber, and then it would drive around, grab the inner tubes in this horizontal position, go over the rack and drop it, and it would just swing in, and it worked so well. It was just ridiculously easy just to like grab up inner tubes and just drop it. And that's actually what a lot of the competitors did in 2007, a lot of the successful ones.
Yeah, I remember you driving this around, and I got the chance to drive it around once, and I was just amazed at how good it was. And like compared to how bad our manipulator was the previous year, like a lot of teams struggled with picking up those inner tubes, us especially. And this thing just worked so well. And it was like, it gave me a ton of confidence, like, oh, we're going to do great this year. And what are these cool things called pneumatics that you put all over this thing? Because we didn't have pneumatics in my time on the team, on the robot, up until that point, I don't think.
Yeah. Back then, pneumatics was a little different than it is now. You used to have this very large onboard compressor, and you didn't have these very lightweight tanks that you do now. Now you have, I think, for these PVC, polyethylene pressurized tanks.
So the interesting thing is, we actually went, not this year, but the last year, we got a huge aluminum tank, like 2 gallons.
Oh, really?
Yeah, because we had a ton of pneumatics on the robot. But this year we didn't have as many, so we did use the plastic tanks that you're talking about.
Oh, okay. So back in, say, my time, they used to have these very small stainless steel tanks. Each of them was very heavy and a very small volume. So teams generally didn't have as many pneumatics because it ate up a lot of your weight, and the compressors were very inefficient, so they didn't have as much. But this one didn't require that much pneumatics.
Actually, with compressors, there was a period of time, I'm not sure if it was during this period as well, you were allowed to have an off-board compressor so you could load up your tanks before the match. You didn't have to put the compressor on your robot. But
Oh yeah, we still had that back then, yeah.
Yeah, now, so we did off-board compressors for years, but now you have to have an onboard compressor. But they're really small, so you can get like a pretty light onboard compressor. We try to keep it as possible. It's kind of crazy.
Is it just like one? Is there only one type of compressor nowadays, or?
No, there are many types, and the one you're talking about still exists, and you can still get it in the kit of parts, I believe. And a lot of teams use it because it's kind of like the default. But we just purchase a different one.
Yeah, it's kind of crazy that first has opened up the types of brands that you can use, the types of models.
Yeah,
it used to be like you had the standard kit of parts. Here are your 4 motors. Here's your 1 compressor. That's it. You can't go outside of that.
Yeah, and today it's like brushless motors. So like the brush motors are almost like they're still there, but no elite teams really use sim motors anymore.
Okay.
Or like they made a bunch of sim like miniature motors, the mini sim and the bag motor. Those aren't really used as much anymore. It's all about these brushless motors because they have a ton of power and are very light. So, and you're allowed to use as many as you want.
Really?
Yeah. So, I mean, you're limited by the number of ports on your robot and your battery's power.
Okay. Well, I think that's fair, and that makes sense because in real engineering, who are you limited by? Size, weight, cost, power. So it doesn't matter if you have more or less motors.
No. Although I always like the challenge of where are you going to distribute your motors? How many motors are you going to put on your drivetrain? Stuff like that. Okay, so let's hop in and watch the game animation.
I do want to bring up one point about the robot.
Yeah.
This works great, but that's with hindsight, like after you go through a competition, you see what robots work well. So you know what to do, what to build. But if you've never seen it, it's hard to find a design. So you try to think of all these crazy designs and try to put it together. And sometimes it works, sometimes it doesn't.
Yeah. So 2 things on that point. One, this past year, we actually put a 4-bar on our robot for deploying an intake. It works so well. And it's the first 4-bar we've built on a robot since this.
Really?
Yeah, like we always talk about it, but it never gets put on. There's always like something else wins out because either, a lift. If you want just linear motion, you generally want a lift, right? If you want to go out, you want an arm. 4-bar doesn't really come into play. It's rare that you want to have stability so it doesn't turn, and you don't like usually when you want something to just go up, you don't want it to go out.
Okay, yeah. Interesting.
But for deploying an intake, it actually made a lot of sense for us.
Yeah, I remember we used to do our robotics lessons outside of the robotics lab. We go to like someone's house, we do like engineering lessons. Our 4-bar linkage was like kind of like standard course topic.
Yeah, I mean, I bring it up in my class a lot. The competition that I have my students compete in, sometimes they'll build 4-bars because I teach them how they work.
Okay, yeah.
And the second thing is, you mentioned like looking back at a game. They actually just announced that they're repeating last year's game for this upcoming year.
Oh.
Yeah, because a lot of teams didn't get the chance to compete at all. A lot of teams, and there's various reasons.
Okay.
Not all of them, but money, I'm sure, is part of it.
So you're saying they first probably invest in the field or something?
Yeah, first invest in the field. Teams built robots, and they might not be able to. They probably lose sponsors, can't afford to build a new one. They say they're going to tweak the game a little bit.
Yeah.
But it's interesting. Now, we played the game. We were very good at it. But we've also seen other teams play the game. And it's going to be up to the kids, but I assume we're going to build another robot. I assume we're not going to want to take a year and not build a robot.
Yeah, because like one of the best part of it is that you have 6 weeks to like figure it out and try to design something brand new. And it's kind of exhilarating to do that. I hope that they keep maybe the field parts the same, but the game dynamics and the game robot design has to change.
So I think what they're going to do likely is make it so that if you are a kind of middle of the road competitor, you don't really need to make crazy changes to your robot. You at least, like, I don't think they're going to make changes to robot size, weight, configurations. I think they'll change like number of balls you can hold or height of one thing. Like, so you still have to make changes, but it's not a huge money cost.
Oh, okay.
But if you are an elite team, you are going to want to rebuild and start with a new robot. So I think that's what they're likely to do, but I don't know.
And that's what 694 is going to do?
I mean, I think regardless, we should build a new robot because that's part of the experience. That's why we do this, not for the competition for kids to build robots. So my opinion is that we should build another robot, but it's going to be ultimately the kids' decision.
Yeah.
But I think that's the way they'll go. I think they'll want to build another robot. Okay, let's watch the game animation from 2008, which, by the way, before we start, I think is one of the best games in First. It was so fun to be a part of.
Okay.
You don't agree? You don't like it as much?
No, I love that game, but I'm very biased because I was driving for that game, and it was so much fun to drive. So much fun to like yell, like compete.
Yeah, it's always fun. It's being on the field, super fun, especially as a driver. Okay. Let's hear Dave Lavery's voice.
Welcome to the 2008 First Robotics Competition and this year's game, First Overdrive. Overdrive is played on a 27 by 54 foot carpeted field. Two alliances of 3 teams each occupy the ends of the field from where they control their robots. Each team is composed of drivers, a coach, and a new position, the robo-coach. The center of the track is spanned by the overpass, which is 6.5 feet above the floor. A 6-foot-tall lane divider runs down the midline of the track. The two structures help define the finish lines on the red and the blue lanes of the track. The game pieces for First Overdrive are 40-inch diameter inflatable balls known as track balls. There are 2 for each alliance. The objective of Overdrive is to have each alliance move their robots and track balls around the track as rapidly as possible and gain points each time they cross their finish line. Bonus points are earned every time a track ball passes over the overpass. RoboCoach stations are located at the corners of the track. Robots start the match lined up against their alliance wall. Starting positions for the track balls are randomly determined before each match. The match starts with hybrid mode, when robots can autonomously navigate around the field and gather points for each line they cross. Alliances will also get a bonus for each of their track balls that is removed from the overpass before the hybrid period ends. During the hybrid period, the robo-coaches can pass signals to the robots to give them cues to alter their gameplay. At the end of hybrid period, the human players step forward and take control of the robots. As teleoperated period starts, robots continue to race around the track and score points each time they cross their own finish line. When overtaking slower machines, robots can signal a desire to pass by gently bumping. Robots can move track balls around the field by bumping and hurting them, or the track balls can be captured and possessed. Track balls score each time they cross their own finish line. 2 points for going under the overpass, 8 points for going over. Robots will have to be built robustly to avoid damage from falling track balls. Track balls placed back on the overpass at the end of the match will earn a special 12-point bonus. Of course, they have to stay there. Good luck, and we'll see you at the competitions.
Okay, so
I remember like the NASCAR thing was for us was very different. So you actually got points for driving around the track. and that was like a new element that we hadn't seen, and we weren't sure how to like navigate that, how like teams would take advantage of that. Would people actually be driving around fast and zipping around? Would they? Yeah, I think most people would have focused on the balls, but it was kind of interesting to see what happened.
It's the other kind of nice wrinkle to it is it's 3v3, but there's 2 balls on each alliance. So it's like, what does that other partner do?
Oh, yeah. And
So
one other thing was that defense was very much against the rules that year. You could only drive in one direction. You could only drive counterclockwise, and you weren't allowed to impede the person in front or behind you. So there was no sense of defense in that game. So you either were one of the 2 scoring robots, or you had to be the one racing around the track. Yeah.
Yeah. So I think, also what's really interesting is the game piece, knocking it off in auto, was very valuable, but you didn't know where it was going to be. So you had to have that human player with the remote control to tell you kind of the placement of the balls so that you could knock them off.
Yeah, so like in Auton mode, you had driver, which in our case was set, and you were allowed to actually give an input. I think you had maybe allow 4 inputs.
I think it was up to 4 buttons.
Yeah, so you press a button and then it could give a command. Some people used it to program the position of the ball. Some of them actually use it to like drive a little bit, like go forward, turn left, turn right a little bit. I remember we started out with a little universal remote, but it wasn't powerful enough. And eventually we expanded that universal remote into this gigantic screen of LEDs that would fire the signal to the robot.
Yeah.
So that we get it.
I don't know what the signals were though. I don't think we had any actions programmed to those signals. Right?
No, there were actions. No. It was. I think ours was trying to do lane position.
Just like shift left, right positions?
Yeah.
Because they're like 3 lanes.
Yeah, originally we had just tried to do go forward and just at least get points or try to do in the laps. We would drive forward, try to turn, and then keep going around. Our turning wasn't that great. Some teams had beautiful snapping, like great PID control turns where they zoom forward, make this quick 90, go around. Ours had to go forward, make the 90, and it would had to correct, find its way to its left turn, and then go. So we wouldn't get that many points.
Yeah, and I think that, looking back at it in hindsight, obviously it's a lot easier, but I think that the best way to approach that is to have, using the IR sensors, have pre-program actions for wherever the balls are placed, right? And then you type in basically like, you have 4 buttons, so it can be, first button and second button means this. You only have 4 buttons, but you can do like a combination of buttons means certain things. But I don't think our software was at that level. That's actually the next thing I want to talk about. Is like, what was our software team like back then?
Our software team was run by Danny Chu, and he did a great job. The programming, the actual driving of the robot worked perfectly well. Never had problems with programming in that terms. And then this, I think, was one of the first years that programming actually got the robot early, ahead of schedule. So they actually had a lot of time to play around with it and tweak it. So previous years we've had like very good Auton routines. This year we were focused on like the LED portion, trying to get those commands in, that I guess we didn't have our Auton working as well.
Yeah, I think Danny was really brilliant.
Yeah,
like I believe he was like the best mathematician in the school, right?
Yeah, he was probably the best mathematician his freshman year.
Like he was like math prodigy.
Yeah. So I remember the programming. So some people would do kind of like dead reckoning, where you try to like count the number of rotations to go forward, and then kind of like count the number of rotations of your wheels to kind of turn sideways. He was using the gyros on the robot, so this way he can zoom faster. And if he started drifting, he used the gyros to try to help correct. So that would work great going straight. And then he would try to use the gyros to turn, to make a very quick snapping turn. But then it would overshoot a little bit. So the gyro would tell it to readjust. And that would take a couple of seconds. While if you had just done kind of like dead reckoning, it would have just like counted a couple of times and then just turned left.
It would have been less accurate.
It would have been less accurate, but it would have been faster. And then it could have just kept going.
Yeah.
This is where he kind of like was overthinking it and trying to make it kind of fancier than sometimes we needed.
Yeah. Nowadays, it's, that kind of stuff. There's so many libraries and we have so many software people and mentors that it's like we do all of that stuff for all of our autonomous routines. And it's just a given. Like we don't do any routines without it. But back then it was really, it was Danny. I don't even think we had a software mentor. I don't think so.
I don't think so. I don't remember it. Yeah.
Gene came a couple of years later, or
correct.
a year. And then it was like Danny and Ariel, who was a freshman. It's Jordan, who was like a freshman too, or sophomore.
Yeah.
But yeah, it was like a lot for one person to take on to try to do like the most sophisticated auto routines. It probably would have been better off just going, okay, go forward, turn, go forward, turn. Like forget about the balls, just try to go around the track as much as possible because it was worth 4 points each line you crossed in auto.
Yeah, we had, I remember we had lost a lot of people during the 2007 season when we didn't, that was the year that Cologne was out of the lab. He was sick, got injured, and we had to work at Cox & Co. for a little bit. So we only had a very small group of people there. So we lost a lot of people. And then coming to the 2008 season, there's still some senior people, but there weren't as many as there probably could have been. And we did have a very large team that year, but it was mostly comprised of freshmen.
Yeah, so I think
very heavily that year.
Yeah, I think you did a good job of recruiting people and also a really good job of keeping people, but we just weren't that experienced. Like I was ready to quit the team in 2007 at times for sure because it's like there wasn't robotics. And I feel like you did a good job involving everyone as much as possible, even if their ideas were kind of absurd. Like you did a really good job involving everyone, and we retained a lot of people, but we didn't have a lot of people who knew what they were doing because we missed a year.
Yeah. So
But
Danny was kind of left as the senior guy by himself. I mean, Theo was still there helping around, and a few others. I mean, there wasn't like no one there, but we had great programmers the year before. And unfortunately, they didn't have their senior year to teach everyone, and they just kind of disappeared. That was unfortunate. We lost so much knowledge then.
Yeah. Okay, so I want to talk about the robot, like different mechanisms. But while I do that, I'm going to play this documentary in the background with no sound. Steven, can you just talk a little bit about what this is, what this was?
Okay.
While I play it.
So
actually, wait, before you do that, you can find this on our YouTube channel under the title Robots 101. It's there if you're interested. But go ahead.
When did you put this on the website or the YouTube?
I put it on, I want to say like 2011. I can actually check. This has been on the channel since 2012.
Oh, really? I was trying to find that video. I was like even looking on our website. All right. Yeah, this is a video I've been searching for so long, haven't been able to find it. So what happened was the Wall Street Journal wanted to do a documentary about New York City first. And they asked first, is there a team that we can talk to? And then first contacted Mr. Clone and myself. And we said, yeah, we would love to have someone come in. We'll talk with him. We'll show him what we do. And then he came in, this gentleman named Andy Jordan. And then he just introduced himself. I'm a reporter. I'm going to be recording you for a little bit. And we'll just see where it goes. So for me, I thought it'd be maybe like a 10-minute interview and then that would be it. No, he was there the entire build season.
And competition season. He followed us to every competition.
Yes, I thought it was gonna be a little segment. And then he actually did a 5-part series on the Wall Street Journal website, just documenting all the students, documenting what we did. Sometimes it was like very good. It showed all the engineering that we're doing. Sometimes, and then it showed us at competition, us winning, which was exciting. But then it also showed kind of like the bad part of us losing, where you could see where we were pretty visibly upset when we would lose competition, and maybe not the best side of us, but it was very honest, I would say.
Yeah, it's cool watching them because it's a flashback. It's like it had a lot of genuine moments in it. Unfortunately, I only have half of it. I only have parts 1, 5, and 6, but still, even watching this, seeing everyone, like there are a lot of people here, like I'm in this, you're in this. A lot of our friends who we're still close with are in this.
Yeah. Oh, I remember this scene in particular. So during, I think, week 2 or week 3, there was a terrible stomach virus that hit the team. And then I think half the team got affected by it. I was actually out all of week 3 with this horrible stomach virus. And that was the first scene that Andy Jordan was talking to me. Mr. Colone's like, "Oh, do you want to do an interview?" I was like, "Oh no, I just want to build robots." I was like killing over, holding my stomach. And he's like, "No, Steven, just do it." And I was like, "Okay, where's this dude? Let me just talk to him." He said, "Just talk about whatever you want." So I look around the table to see whatever I can find at a moment's notice, and I grabbed I forget what it was. It was
So I just watched these: a potentiometer and a 10-position switch.
10-position switch, and I was trying to tell him what the difference of the two things was and what's the use of it. It's probably the most boring thing ever because I was just like, "Oh, I just want to go home."
Okay, yeah. So let's start talking about the robot. Let's start with the drivetrain. So we had a single-speed drivetrain, which I think was really great because we never really had gearbox issues.
Yeah. So the year before, we actually had these DeWalt gearboxes that had 3 speeds: low speed, middle speed, and high speed. Low speed for like pushing your people around, and high speed for driving quickly.
And middle speed for nothing.
Or maybe it was only 2 speed now that I think about it.
No, I'm sure. I talked about this last week with Sammy. It was definitely 3 speed, and there was definitely no reason for it. I actually think it had more because it's a DeWalt gearbox.
No more than 3.
Okay.
More. So we're coming into the 2008 season where they had focused on there would be no defense. We decided, all right, there's no point for low speed. Why would you have low speed if you're not going to be pushing anyone around? So we decided to do a single speed, and we decided like how long do we want to take to like zip down the fields? Probably about this amount of seconds. And we decided, all right, we want a drivetrain that can go, I think it was 12 feet per second. About. So that's what we decided on, 12 feet per second, and we would have a fixed drivetrain, and it'd be a direct coupled drivetrain where the motor would not direct couple, it was still change driven drivetrain with motor connect to a mill axle, and those would drive the front back wheels.
So I believe we used the kit chassis that year. It was the first time we used the kit chassis.
Yes, we did use the kit chassis.
But we also started out doing something really weird with it.
Yeah, we
talk about that.
Yeah, we were actually going to try to do Ackerman drive. Ackerman drive is the type of drivetrain that you have in a car where you have the back wheels providing the power and the front wheels actually turn, and they turn not just in a 4-bar linkage mechanism, but they actually also have a certain angle. So as you're turning, the angle between the wheels are different. So this way you can go around turns much easier. There was a lot of
Issues?
no. There were no issues. There was a lot of people who weren't into the idea. And this is where I thought, like, it's okay. I like being creative. I wanted to take this chance. Let's try it out. It'll be fun at least. So we actually, to appease both groups, we actually built the Ackerman drive so that can be done in 2 ways. So the Ackerman drive had the turning, but on the shaft of the Ackerman drive, there was a pin so you could set it in. So this way you can set the position. So this way it doesn't turn. So this way people who just want a standard like 4-wheel drivetrain could also get that.
You can actually see it right here. You can see the original, and there's a potentiometer in there.
Yeah, and
pretty jankily mounted potentiometer.
Yes, it was. It was our first try. So I was leading that part of the design. But then that was the week I got sick, and then we were a week behind on our drivetrains. And then while I was out, the groups started driving around, started testing it. Didn't drive great. So when I came back, they were like, all right, it's not driving great. What are we going to do, Steven? I was like, all right, let's go with what we know. We're a little bit behind. Let's go with tried and true. Let's go with tank drive. So we pulled out the mechanism, pulled out the potentiometer, pulled out the driving motor, and then pinned it in with a permanent shaft.
Yeah, and we put on Omni wheels. I think I think that was the right call, because ultimately the benefit of it is so insignificant, I think. And if it gets stuck in a bad position, you just can't really drive.
Yeah. We for some reason thought that it would help us with the turning a lot faster, because you're not really reversing at any point. You're not making these like very quick, like you're not spinning in place. So that's how we thought we would do it, but that's all right. Did any of the teams actually have a good Ackerman drive?
So 2016 had a pretty good one. They were on our alliance partners in Trenton.
Yeah, that's what I thought I remember.
But the issue with that is, it's like you have a finite amount of resources, right? So if you put a lot of resources into this kind of thing, where are you losing out? Where are you missing out? And I think that if we hadn't changed it, I think we would have spent a lot of our season improving this as opposed to improving the mechanisms, which we did improve throughout the season, which I think netted a lot more benefit.
Sorry, my cat's just being a little.
You got a cat? You have a cat and birds? Feels like a bad.
We got lots of animals. Yeah, you're right. So I was responsible for the drivetrain, and I had Adam Yabrodi working with me.
Who's Sammy's younger brother?
Yeah, I think I had Seth Berg working on the tower mechanism, and I forget who I had working on the arm mechanism. And you're right, we divided resources to really build this. And I do remember like the arm and tower mechanism needed a lot more work by the end of the season. So if I had spent so much time on the Ackerman drive, I wouldn't have time to work on any of the other components with the team, and the robot would not have been as good as it was.
Yeah, and I also think that because you were able to do that, it like really helped, because you were able to lead all these people who were, a lot of them were inexperienced and never led a project before.
Yeah,
you were able to dive in and help them.
Yeah, so during the competition, we did a week of design prototyping. Second week, we had our design. We had it fully CAD'd out, and I took the time to take everyone's idea, put it into like one single CAD file, dimension everything, and then just had documents of parts for people to build. So this way they can, even if you didn't have experience building a component, you could still do it. If you look at a robot, most of the parts aren't actually machined. They're mostly just handmade. They're like drilled with a hand drill or cut on the bandsaw. Wasn't that much milling taking place.
Yeah.
Just, yeah.
Can you talk a little bit about, the arm, puncher, tower mechanism, how they work?
Okay, sure. Do you have any pictures of the side?
Let me see here.
Kind of like see the tower a little bit.
Here, do you need to see the bottom of the tower?
No, maybe if you
That
have
has
one.
So, because that was modeled after Larry, right?
Yeah, it was. So we could have built like a 4-bar linkage, like how we've taught in class, but we actually went with the tower design connected to a pneumatic that would shift the tower up into scoring position, and then the arm would raise up and release the ball, and then the tower would shift down to get lower to the ground and then pick up the ball. So the puncher was never a part of the original design. The original design was to grab the ball, lift up, raise the arm up, and you can see that there are tusks. Oh, stay on that picture. You can see that the tusks there are parallel with the bar. They were actually not supposed to be parallel. They're actually supposed to be pointing downwards a little bit. So this way, when you released it, the ball will roll off the tusks over the bar. What happened was that the tower was supposed to be a certain length. So the tower was supposed to be actually a little bit longer. So
this one down here?
Yeah. So when it was in its lower position, it would actually have that longer diagonal, and to be within the original robot dimensions of starting out. What happened was that someone had built the tower so this way when it's standing up, it would be within dimensions. So that actually made the tower a couple inches shorter than it should have been, which caused us to raise the arm a little bit higher than we wanted to, which creates the tusk actually pointing up rather than down. So it was really tough to get the ball off our manipulator. So what we first tried to do was we just open the arm up and then try to drive forward really quick, and just hopefully the momentum would push it over. It wasn't reliable. So then that's when we thought of the idea of using a pneumatic to punch the ball over. So actually,
to do it.
The first time we built it, the pneumatic just pushes the ball over. So you just extend the pneumatic, it slowly raises, and then the ball just kind of goes forward. Later in the build season, we actually did change that.
Yeah, you put like surgical tubing, or what'd you do?
What we did was we actually put a trigger switch on the end of the puncher. So the reason why the puncher,
the catcher one?
Yeah, you had like a fork so if you had the puncher going out, there was like a little circular disc at the end, and this fork would go into it. So you would extend the pneumatic, let it pressurize, and then you pull back the pin, and then it would fire out.
We added that later in the season, like during time.
We did that after Trenton for New York.
That's what I thought, and that was a huge improvement, because then we could really push that ball a lot further.
With the punching mechanism, we could actually fire the ball a lot faster, so we didn't have to like keep in that top position, push it out, let it roll out, and go over. We can actually punch it, and we can also do it further back from the overpass. So this way, as we're making the turn, we could raise the tower up, punch it across, start lowering our mechanism, even as the ball is in the air, and then go through the underpass. The reason why we had to do that trigger mechanism is because of how the air expands in the pneumatic. So that normally, if you don't have the trigger mechanism, it extends slowly because the air has to go through the inlet ports, and that creates a lot of pretty much pressure drop. and that prevents air from going through quickly. However, if you kind of let the pneumatic expand a little bit, fill that part with air, this way, by the time when you pull out the trigger mechanism, the air in the pneumatic is what expands, and then you're not being limited by that port that the air is going in.
Yeah, and it was really clever. I never thought of something like that, and it really worked really well. I'm surprised though it didn't damage. Hey, there's you. I'm surprised it didn't damage the puncher piston more firing into it like that.
Yeah, I am also kind of surprised that that part never broke. Other parts broke, but the piston never broke. We even had, we tried to do other tricky things to try to make it go faster by, like, say, putting the solenoid valve on the actual piston itself to try to reduce some pressure drops from the source side. But then that, like, solenoid being attached to the piston at such an aggressive place actually eventually broke that off during one of our matches. So we pulled that back, but not the actual piston itself.
Yeah, and I think I seem to recall that we set it up so that we weren't using much pressure to retract.
Yes.
Like you had a regulator back and you just had surgical tubing for it to retract.
Yeah. So for the tower itself, we had actually two pressures running on the system. High pressure for the puncher and low pressure for the tower piston to try to save on energy, save on air. Because if we didn't manage our air, we wouldn't be able to recharge the tanks fast enough for us to be able to punch the next cycle. Also, we would just could be consuming too much electricity. So the pneumatic that was attached to the tower ran on low pressure air to slowly raise it up. And then it had springs to retract it back down. So this way, we didn't have to use pneumatics on both sides. We also didn't use, I'm trying to remember why we didn't just use like a spring-loaded pneumatic. Oh wait, no, they didn't have that back then, did they?
I'm not sure.
Okay, so now
nowadays we do that a lot. We put regulators on like every system. We do calculations on, how much air does this part really need to use. We, start there and work our way back, try to save air, because ideally we don't want to run that compressor at all during the match because it sucks power and slows us down.
Yeah, I can tell you, like, one of our matches, in the last 20 seconds, our robot was struggling because we were running out of power.
This year it wasn't as big of a problem because our robot didn't draw as much power, but in 2019 we had a big problem with brownouts, so we would legitimately like unplug our compressor before going on the field. Disable it in code, but also sometimes that didn't work great.
Okay. So you have it on the robot, but you wouldn't actually use it.
Yeah, we would unplug it before the match. So like we compress before the match, and then we just, because we ideally you would have, we would always have it so you have enough air in the system to work in any match, so that you don't need to use the compressor. The compressor just has to be there. Cool.
I remember the pads that we used for the gripper mechanism were actually materials that they were using at Cox & Co. They were these special extra grippy foams.
Yeah.
We tried a lot of different foams. They didn't work as well. Then Tom Ferguson brought some from work. It's from his special little magic workshop, put it on, and it worked a lot better. So we had tons and tons of spares made out of this part.
Yeah, it still wasn't, especially at Trenton, I feel like the grip wasn't great, but we did really well. I believe we definitely seeded in the top 8. I think we seeded like 6th or something, and we ended up being captains. It was the first time we'd ever been captains outside of New York City.
Yeah, that was something I was really proud about. I didn't think that was going to happen. But when we made captains, I was so excited. I think it was a testament to all the hard work we had done that season. Even with all the setbacks we had, meaning the loss of 2007, the week we lost to everyone getting sick. But we were still able to finish the robot 1 week early and had 1 week worth of driver practice. And I think that helps us with our first competition because our drivers are much better then. They're much more comfortable. They've gotten a lot of the bugs worked out of the system already. And you have less failures on field if you play around with it more.
Yeah, break faster is what I always like to say.
Yeah.
Oh, I forgot to wait. Hold on. We got to go back to the build season because I forgot to mention the most important robot mechanism, the Blay frame.
Oh. I think this. Do you want to show a picture of it or a video of it?
Yeah, I'll find a picture of it. I don't have the video of us trying to tip over with it.
I think this was your moment that got you really excited about robotics. That got you really hooked into it. So, where is it?
Here it is.
Okay, so we were driving the robot around. It's a kind of when you're putting the ball up, the robot is quite tall, and it could potentially tip over. But most of us, I'd pretty much say 99% of us said that's not going to be an issue. If you tip over, we can probably flip ourselves back over. But there's this kid on our team who said that he had watched The Simpsons and he had this idea of like, oh, if you tip over, you can just put on these legs to save us. So he started working on it. He said, no, he'll make it very, very light, make it out of like thin aluminum tubing.
I actually started with PVC.
PVC? Okay.
I started with PVC and then it would just bend with your hands. Like,
So we attached it to the robot just because, like, sure, why not? I mean, we have the extra weight. This kid's really excited about it. There's no reason why we shouldn't do it. So we threw it on. During our next, like, in-school practice, we were doing like a spin test holding the ball. And we actually flipped backwards with our arms extended. And then we landed backwards, and then we caught ourselves, and we're like, "Oh my God, this is great! The A-frame finally works. Joe Blay is amazing." Then we go over to the robot. We see that the ball is what's holding up the robot, and we take the A-frame and we just swing it, and we see it's freely swinging, doing nothing.
So I maintain that if the arm was at a slightly different angle, it would have still held. It was a flawed test for sure.
Flawed test, but
not scientific.
The point was proven that you really should have something to protect you from tipping over because our robot did tip over. And I do remember in competition, it happened a couple of times actually, where we would try to put the ball up and maybe get our tusk get stuck. So in the forward position, our tusk would get stuck and we try to pull back and we'd fall back. And the A-frame actually saved us a couple of matches. If we didn't have it, our tower would have been damaged. Our gravity mechanism would have been damaged for sure. So it was a great mechanism.
Thank you. The first version of it was very heavy, but then we got it lighter. I think it was under 2 pounds for sure.
Yeah, under 2 pounds. Yeah,
it was probably like a pound. But I had some mentor help, and it was just like it was good because it was my first mechanism that I put on a robot. I felt like I had lost my sophomore year because of Tom. I basically couldn't go work on Tom at all, and it was really good. It got me really excited, and I think it had a lot to do with my enthusiasm going forward. It was just a lot of fun. But a lot of teams had like a lot simpler, clever ideas where they had like just 2 little stilts that came out and would touch the ground when their lift would come up. I thought that was really clever.
Our robot was definitely the only one that had this little cape that was like flying behind it.
It was their signature.
It worked. It worked.
Yeah, it was really fun to work on. Okay, so we were talking about Trenton. Let's jump back into that. Our grip on the ball, I remember, could have been better, but we made the top 8, and I remember going through the competition. Jay was head of strategy, and I was kind of his second. We really started realizing how important the autonomous was because so there are 4 lines on the field, and if you cross one of the 4 during auto, you get 4 points, and if you knock one ball off, it's 8 points. But in teleop, hurdling a ball was worth 8, and doing a full lap was worth just 2 points. So, just getting those lines in auto became so much more, like, we realized, wow, this is so valuable. And we were only capable of, like, doing 1, sometimes 0.
Sometimes 2. We got, I think.
By champs, 2. Definitely not at that point. Sometimes we just didn't move in auto, and I just still don't know why. But Jay and I identified these 2 teams that had just great autonomous routines, and then we got to pick both of them, and we were so excited. We got 1279 and 2016. 2016 was just a lap bot that did 5 lines in auto, so 20 points right off the bat. And 1279 would knock a ball off, sometimes catch it.
I think this was a great evidence of good strategy. I think this was the first year that strategy was a really big, important factor for our team. We didn't really have a strategy team before. We used to have scouting sheets to help you pick who you wanted, but no one had actually gone through the scouting sheets of everyone's strengths and weaknesses and seeing what we were weak in, which was auton, or how we could optimize points. That was something that you guys did that year.
Yeah, we started it in 2007 champs, but really going into we never. I felt like the director of strategy was never a really strategy person until 2008. So it's after what happened in 2007 at champs, you guys appointed Jay, and I didn't really have the position, but I was his second, and it was just really great too.
I think that year you picked the Mighty Monkey wrenches.
That's right. They're the little lap bot that's going crazy on the field.
And I think all of us were who is that team? None of us knew who that was.
They were ranked something ridiculously low.
Yeah. And we just didn't, we weren't upset with it. We just didn't understand it. And then during our first match, when they just zoomed around the field, scored so many points, we were wow, that was an amazing pick.
Yeah, they might have been the best team on our lines. They were so freaking good. They scored easily 35, somewhere between 30 and 40 points a match, 20 in auto, and then just laps. So, and it's you look at our scores, and we were in the 80s, they were half our lines, and they were a second pick.
Yeah.
Fast.
It's crazy how important lap bots were that year.
How important what?
Lap bots were that year.
Yeah. But
the Robo Wranglers probably was the most famous lap bot, where they had this insane 6 sim combined swerve drive. Oh my God, it was a beautiful piece of engineering.
Yeah, I'm gonna show a video of it right now. But I think in terms of strategy, though, we were really good at mass strategy. We were really good at alliance selections. But I think the thing we were really lacking was contingencies. One thing would go wrong, and then it would snowball. A little thing would break on the robot, and then it was just what are we doing now?
There were definitely a number of matches where small things would break on it, and then our system would just be down. I remember one match where one of the keys for the drivetrain just sheared. That was unfortunate. And I remember what we had done, why that had happened. I remember one of the mentors, we couldn't find a key for the drivetrain, so one of the mentors had built a key, which is pretty much what you put on so the motor has a keyway, and you put a little pin to connect it to the sprocket. Usually they're made with hardened steel, but one of the mentors had built one out of a washer. He took a washer, just kind of trimmed it down and put it in. That did not work at all. It just sheared right away.
For a little bit.
It worked for a little bit, and then one of our matches, it just sheared as soon as we started, and we lost that match because we couldn't move. We couldn't figure out why what happened. We thought, oh, maybe it's programming, maybe it's electrical, because when we got back to the pit, we started operating the motors, everything was going, and we couldn't figure out why. And then someone said, hold down the wheel. They held down the wheel, and the motor kept spinning, and we were all right, it's that key. That's
Hope you didn't hold it with your hand.
no, we used some kind of pliers to grab it.
Okay.
And then there was luckily a workshop at that competition. I think it was a NASA workshop. So we took a whole part drivetrain, rekeyed it, put it back in, and then we didn't have problems with it afterwards.
Nowadays, it's all hex shafts.
Oh, much easier then.
Yeah, much easier. But there's still some, like you need to do, the motors still have a key way that come off, off of it. So there's like couplers where it's basically a hex shaft with a hole the size of the motor and a key slot. So you put that on the motor. So you still need to have keyways and you still need to know what you're doing there.
Okay.
But it's definitely like you don't need a keyway for everything.
Okay. I know we had like a number of issues with some of the PWM cables slipping out and some of the pneumatic cables being sheared during a match. I actually don't know how it kept happening, but the tubing that would connect that went through the tower to the arm mechanism, that tubing somehow sheared, I think during 3 of our matches, which was frustrating. So frustrating.
Yeah. Oops, I just paused the share. Okay, you can still see my screen, right?
Yeah.
So at Trenton, the best team were 103 and 25. And I just remember like showing up to Trenton and seeing 103 in the practice matches and being like, oh my God. They would like knock off both balls in auto, and they had this catapult. And those two teams just dominated the whole competition. We ended up playing them in semi. Sorry?
103 was Cybersonics?
That's right. Good memory. Yeah, we ended up facing them in semis. They beat us in the first match, but the second match, we had a chance because our partners kept it close, but we didn't move.
Yeah. I remember we were so frustrated. We thought like, oh, something's wrong with the first system or something. And then at the very end of the match, someone bumped us and then we started moving. And then we realized it must have been some kind of electrical issue within our robot.
Yeah, I think we determined that it was the battery was unplugged. Like
or it wasn't fully connected.
At the not at the where the terminals connect, but in the connection from the terminal battery was loose. And then when a team bumped us, I think that's what we determined. We weren't sure. I just remember Joe who was the drive coach back then, being so upset that they wouldn't give us a replay, that when they were setting up the field, he came on the field and punched one of the balls off the rack.
Yeah.
And cut his hand.
Yeah, we were all pretty upset because did we go into a third match?
No.
That one?
No, but in the second match, like our partners actually kept it really close. And we felt like if we were in that match, we would have had a real shot.
Yeah. Oh, well. It happens.
But it was still like an amazing competition. It's still like a great time.
Yeah. And even with that, I remember going on that bus and being so proud of the whole team and what we had done at that regional. That there were some issues, but they were all fixable issues that we could get right by New York. I had no problems with that. Everyone was excited that we had actually done well at our first regional.
Yeah, and I remember after New York just being like, all right, what can we make better? What can we improve on this robot? And just watching the matches time after time. Okay, what can we make better? What can we make better? And then I think the two big changes we made between Trenton and New York is you added that fork thing that you were talking about, and you retracted the puncher so that the ball could be in the gripper more.
Oh, okay, yeah, I remember that.
And those two things I think made a huge difference in terms of our gameplay. And I remember trying to figure out a way we can improve ball gripping and staying up late and chatting with you on, must have been AOL.
Yeah.
Were you, I think your AOL screen name was Dude with the Mood, something like that.
Yeah, back then.
And just like brainstorming idea. I remember thinking, chairs get really sticky when they're hot. And then I like cut open a chair and tried to make like a grabber piece, like add on to the gripper, and I would
Yeah.
like heat it up and see how it did on the ball, and it didn't do anything.
It didn't work as well as our aerospace materials.
No, it did not. But Seth eventually made those like teardrop shapes
Mm-hmm.
that seemed to grip the ball a little bit better.
Yeah. Oh man, I remember at Trenton, that was like my first time competing, and how nervous I was. Like my stomach was just a mess during the whole competition because I was so nervous every match.
Yeah, that happens.
Yeah, and then sometimes you're up so late at night trying to think of strategy. By the time you're on the, I don't know if this has happened to anyone else, but I actually fell asleep during one of our matches at the controls because I was so tired. And Andrew's my partner. He was the one controlling the drivetrain. He got ready for us to shoot, and Andrew just sat there waiting, and then nothing happened. Waiting, nothing happened. Steven, and he's like, Steven, shoot. I was like, oh my God. And I pulled the trigger, and I just woke up.
Nice. Not nice. Terrible. If I was drive coach, I would have been so mad at you.
Maybe that's why we didn't win that competition.
But I remember between Trenton and New York City, I really was like watching matches like crazy, not just ours, but everyone else's. And no one else on the team did this other than you. I just remember like late night talks about like, ooh, this match and this team, and watching the Hawaii regional because it was in a different time zone at like 2 a.m. Do you remember that?
Yeah, I remember that.
Because it had like Pink was there and 25 was there and 254 was there, and we're just like going through watching it. That was just like so much fun.
I think for me, I didn't have as much of a strategy mindset as you did. For me, it was just like looking at the cool design, seeing, oh, this team looks pretty good, but I didn't have a very methodical approach to it like you did. You considered kind of look at the opportunity cost of like selecting that robot as a partner. How many points could they give us? Because you can't just pick 3 scoring robots because there's only 2 balls. So you have to kind of optimize around that.
Yeah, I was just like obsessed with trying to think of, okay, what strategies are they running? Well, why does that work? Why does that not work? What should we do? What can we change? So we went on to New York City, and we made all those shifts, changes to the robot that we mentioned. And this one's the one from New York City, so we'll watch this as we talk about it. We did like pretty well. Can you talk a bit about New York City and how that went?
You're gonna have to refresh my memory a little bit, but I do. I'm just gonna look up the scores from that year just to kind of remind myself what happened. It's been a long time.
Yeah, fair enough. Well, we were doing really well. I think we were like the entire competition. We were in it for the top seed.
Yes, that is correct. We were doing surprisingly well.
And I felt like we were going out there and we were playing. We were definitely one of the best spots there. But I think go ahead.
So we had won our first 4 matches using our weaker punching system, and then we said, all right, we're kind of up ahead, but we know it's kind of weak. So let's try to figure out how we can improve this trigger mechanism. Let's figure out how we can improve trying to score better. So we kind of almost sacrificed the match to play out with our solenoid system, where we could try to that's what I was talking about. We should try to connect the solenoid directly to the piston to try to decrease the amount of pressure drop you have through the tubing, see if we can fill up our piston faster and kind of punch faster. But that backfired because it broke during one of our matches. We were still able to score points even though our pneumatic wasn't working, by kind of grabbing the ball, picking it up, opening it, and just kind of like using our momentum to kind of throw it over a little bit. But we did lose the match.
Yeah, but we were still like, I think till the end we were still in it for the top seed. But I think when I reflected on this competition specifically, I realized that we hadn't paid close enough attention to the ranking system and what the tiebreakers were. And that year, the tiebreaker was, it was wins, losses, and then it was combined opponents' pre-penalty score. So we would do things like, we were up by a lot, but we would knock off our opponent's balls. So that would remove 12 points from them. We would do like little things like that hurt us in the rankings. I just remember looking back at that, it's like, well, we got to pay closer attention to the ranking system. And ever since then, it's like whenever I'm, when I was a student and as a mentor, I'm always like, okay, let's actually jump to at some point during kickoff, let's look at the tournament section and make sure we know how the ranking system really works. Because that's the thing a lot of teams overlook. And actually, if you're trying to battle for that top spot, which we've never really done before, you really do need to know that stuff because it's going to come into play.
I remember that. Did we try to implement that in New York?
No, definitely not. I realized it after New York City, but I think we tried to implement them at Champs. Not that it made a huge difference. But we implemented it in future years. We kind of understood it more in future years. So it's a big lesson learned. We were captain of the number 3 alliance.
Yes.
And then I remember we debated a lot which team we were going to pick first between Saunders and 395. And both were really strong, but I think we should have picked 395. We ended up not. But no, in that moment, I was like, I agreed we should pick Saunders. Like Jay and I agreed that we should pick 2344. 395 was a little bit of a riskier pick. And
during that, so strategy was entirely responsible for our alliance pick. I actually have no idea who we're going to pick until you actually say it from your mouth. Because I knew that you guys were looking at it much closer than I was, and you guys were just better at it. So I had complete trust in what you guys were doing.
Yeah, and I think that was the first year that really happened, and that was huge for us because we felt like we had ownership and agency over what we were doing, and that you were going to trust us, and that's something that has really continued over the years, and I think is really good because those strategies. Like we have today's strategy team is like 10 people, 15 people at times. Yeah,
really?
Yeah, it's huge. We have maybe it's just my belief because I'm part of it, but I think we have one of the best strategy teams in the country, like as good as anyone else. Like I'll put our strategy team up against anyone else's.
I think I remember on Chief Delphi that one year you had put up your scouting sheets for other teams to look at.
Yeah, I mean, I don't think that's like our scouting sheets are great, but I don't think that's really our strength.
Yeah, but I remember you were so confident in your scouting that you were willing to help other teams who may not have, or who probably younger teams who weren't looking at this, who probably should consider it.
I mean,
they have who they want to pick as the alliance members before they go up.
I mean, that's 6-9. That's FRC. That's what you're supposed to do, right?
Yeah.
That's what they teach.
Yeah.
So we captained the number 3 alliance. We ended up picking Saunders, and I think, I reflected a lot on that specific pick, just like that year over the years, and I think that we picked Saunders because they were better in terms of consistency, but 395 had great spikes where they were like one of the best, if not the best robot there. And from the 3 spot, we really should have been taking that risk.
Yeah.
Whereas I feel that we were in the 1 seed, we probably should take the more consistent team.
Okay.
But we still did really well. We came close to getting to finals. Do you remember what happened in semis?
I do remember in semis we were going against a team. Was it 637? I thought were they the match? We had. This is a team we've played against at New Jersey and New York a couple of times. We've always had. We had a small rivalry with them because we felt that they would play very aggressively against us. And then a lot of matches, our robot would come broken afterwards. And thought that was unnecessary.
Yeah, and they did a good job taking advantage of the rules because, our arm was so far out, right? And they would just catch it, and it would be inside their frame perimeter. They would basically defend us by catching us, and then we would get penalties because we were in their frame perimeter.
Yeah, that was rough. We get penalties for that, and I remember the penalty that we lost was a line infraction. So there was a rule where you're supposed to always maintain motion, and you weren't supposed to impede the motion of another robot. And you had a certain amount of time. Was it 3 seconds or 10 seconds?
I think it was 3 seconds.
Whereas at 3 seconds, if you're in front of another robot and you're just stopping them, you have to move out of the way. But that wasn't happening. So they would drive in front of us, stop, and then we would try to drive around them, and they would just try to go in front of us during the whole match. And then there was one point where we were near one of the line markers where we couldn't get around them. So we reversed a little bit and then went around them. Because we reversed, we had ended up going over one of the line markers, and that counts as a violation of going backwards on the track. And then we lost the match.
Yeah. I think that penalty is one of the worst I've ever seen in FRC in my 15 years, because it was 10 points. So it's as much as hurtling a ball and going under the overpass with your robot. So 10 points. It's an extreme penalty for, you just go over a centimeter and 10 points, right?
Yeah, I was hoping that they would at least change it so that if you're all the way across the line and then come back, that would be the penalty. But as soon as you break the line, you couldn't reverse at all.
Yeah, that sucked. We lost.
Sorry.
We lost. I think we ultimately would have lost in finals anyway because the team that was the number 1 seed was just so freaking good, so dominant.
Who was it? The Wizards?
5-5-5.
Yeah.
They were really good that year. They were good.
Yeah. I remember my mom coming up to me about that also. So this was the first competition that my family came to. This is where they actually got to see what I did, because then for all these years, I would just be in lab working late, and then just coming home late. And my parents didn't really understand what I was doing. I would tell them it's robotics. They would kind of get it, but they didn't fully understand why I was so passionate about it. Then they came to the New York City regional and they saw us compete. And I just remember how excited my mom was for me. It's like, oh my God, this is amazing. This is incredible. I love watching you play. I love watching these robots. They said the robot looks great, looks fantastic. And she said, but 555 looks better.
Classic Asian or Jewish mom.
She was like, yeah, that 555 robot is amazing. I was like, oh yeah, I know.
My parents came to the competition 2 years ago, and to the kids, they were like, "You guys are awesome, but that 1796 robot looks better." Like, what are you guys doing? What are you doing?
Yeah. Sometimes, I don't know. You want to always be the best, and you're hopeful that you're in the top seed. But sometimes there are outstanding robots that have really good build seasons. They were consistent. They had a good idea from the very get-go, and they executed very well, and they just performed consistently. And those are always the teams that are top seed every time.
So this was our second competition. We lost in semis, so we hadn't qualified for champs. But then the awards happened, and we captured here. If I can get this to open, here we go. They announced us for Engineering Inspiration, which is the second to last award they're going to announce, and we qualified for champs. It was just, for me, I was just so freaking happy because I really felt like
I don't know. I thought our robot was very good that year. I was actually in the pits creating up our robot, thinking that our season was over, and then we were just going home. And then I heard it announced, and I was like, was that us? Oh my God, are we going to go to nationals? Oh my God. And it was amazing to feel that way because I thought we actually did deserve it. We built a great robot that year.
Yeah, and we literally did. I felt like we did our best. Whatever our best was, we did it.
And I can attest that probably one of the reasons why we got the Engineering Inspiration Award was because of like Betsy and Seth. The judges had come around talking to them, and they had a speech they already were kind of preparing for it. They had already thought about like what they wanted to say to the judges if they came by and how to describe the robot. Talk about some of the aerospace materials, talk about the engineering that went into the puncher, things like that. I remember for 2000, no, it was still the 2008. I remember when we were doing it at Trenton, judges had came to me to interview about engineering inspiration, and they asked me what my favorite part on the robot was. And I said something very silly. I said something, oh, I love our Barry box cover, which is like a very small thing. But I was actually kind of enamored by it because it was like this very sweet, like little red box on the front that was hinged, that had a little latch on it that I think Sam Unger built. I thought that was pretty cute. It worked very well. Batteries came in and out very quickly, but it doesn't highlight the engineering that went into the robot, and that was a mistake on my part.
It doesn't highlight what you learned, right?
Yeah, it just looks cool, and there's lots of cool things on the robot, but
yeah. So what did Seth and Betsy say when they were asked?
I remember them talking more about the puncher mechanism and the pneumatic system, and the engineering that we had to do, and talking about how the rate of expansion of the air and things like that.
Yeah, I think in those situations, judges really want to know, you're excited, but you're also like, you learn a ton and you can really describe this stuff at a high level. It shows that the team is kind of achieving the missions at first.
Yeah, obviously we build very incredible robots, and there was a lot of engineering that goes into it, but you have to be able to describe it to other people. If you don't have those communication skills, then no one else understands it. No one understands what you're doing, and then this cool thing that you built gets lost because you couldn't transfer that information to anyone else.
Yeah, so hopefully these episodes do some of that. We transfer some information to people. Okay, so we win the EI, and we're on to Atlanta for the championship. And we were in the hard division for sure. Like, yeah. Our division was so stacked. Like, I remember when divisions came out, which like, and that team, and there must have been like, I want to say, of the 60 whatever teams, 63, I think it was. I would say 40 are like playoff capable robots.
Yeah, and the I think it was our team that finally won the whole Einstein, and they dominated in Einstein.
Yeah,
it was like Symbotics, Robo Wranglers, and Thunder Chickens.
That's right.
Yeah, I remember that there were T-shirts made about this, like before nationals. People who were guessing the winners of the competition, and one that was like, combine Symbotics with any of these 5 teams, and it was Thunder Chickens, blah 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 blah, and then throw in Robo Wranglers.
Yeah, Sim Chicken Wranglers, I think.
And that's what won. I can't even believe that.
Yeah, because it was crazy because people were talking about that alliance like they're on practice day.
Yeah, and it's incredible that alliance was even able to form.
Yeah. Like 11, 14, 217, that makes sense, right? 11, 14 seats first, picks 217. All right, I can expect. Yeah. But Robo Wranglers was legit the best lap bot in the world. They were like the alliance captain of the one alliance at their regionals.
Yeah, and I think they were confident in that they were the best lap bot. So they didn't play as hard during the seeding rounds. So which ended up them losing a bunch of matches, them not getting seeded, dropping down. But scouting teams didn't pick up on that, surprisingly. They should have looked at Robo Wrangler's previous performance and know what they were capable of It was crazy that they were the last pick for the best lap robot in the world.
Yeah, but kind of on the flip side of that, there were like a lot of really great robots in that division where, you know, I kind of, there were like, even there weren't, it's not like the picks were so bad that like how did 148 fall? It was like, oh, that's a good bot. No, that's another really good bot. Like all these teams are really good. So it kind of made sense. And, I don't think we played that badly. We did break, which I think hurt us. There were like, of our 8 matches, I think like 3 of them we were broken.
Yeah, that's really what hurt us. The matches we played, we did well. Actually, I think it was the first match, I think, with Symbotics, we actually had the top score at that point.
Yeah, in the world, at anywhere. Yeah.
And that was us, even with us having a small mishap where we were hurdling, and actually we knocked one of Symbotics' balls. Symbotics was also hurdling at the same time we were, and something collided and theirs bounced back, so we lost like one of the hurdles. So we could have scored even more points, and that made us confident that we were on the national stage and we were one of the good competitors, and we should be able to compete with everyone else and hold our own.
Yeah, and it wasn't like it was Symbotics, another good team, and us. It was like Symbotics and us, and we put up those scores. I mean, obviously Symbotics put up most of that, and like they did 6 lines in auto or something and knocked over both balls. But we did, we did a line or two, and we hurdled a bunch of times, and we capped.
Yeah. At that point, I thought, oh man, maybe we could actually go into the playoffs.
Yeah.
But then the 3 matches where we just didn't move at all, it's heartbreaking.
Yeah, it was like, I don't think we didn't move at all. It was like pneumatics were out, or this X broke, Y broke. It was just, there were too many little things that went wrong. And we just weren't able to recover. And with all the good robots, we just kind of slipped through the cracks and didn't get picked.
I mean, even though I was sad that we didn't get picked, I wasn't like, oh man, this is unjustified. There were just too many good teams there, and all the other ones just performed consistently match after match after match. If I were another team, I probably wouldn't have picked us then, because there were so many good choices to pick from.
Yeah, but the one thing about it was, 11-14, they were really good. You should see them here.
Mm-hmm.
But, you felt like, looking at that robot, there wasn't anything crazily good about it. It was just a great design, right? It was simple. It worked well. It worked consistently. But there wasn't like, this robot's built by NASA, that we can't achieve that. I felt like, well, if we take our lumps, we learn from this, we get improved, we think about, what makes a good FRC robot design, we could get this good.
Yeah.
It wasn't like, we look at the pink team that was earlier in this video, like, we're not building that.
I think it's always kind of like, I was always, we shouldn't compare ourselves to Pink or to another team like that. We also aren't on their team. We don't know what happens, because we usually say, oh, Pink is the NASA team. They do have a lot of NASA engineers. But we don't know what the students do or how much effort they put into it. So many students work really, really hard, and with different resources and different mentors, you get different results. If the style of learning is on precise machine building, like CNCing, then that's the type of robot you do get.
Yeah, absolutely. And that's not like to disparage those teams. I think, the students under those teams learn a lot, but, we don't have NASA mentors. Like, we have a couple of real world engineers, and then like hobbyists, we don't have like the facilities necessarily that other teams had. But, I looked at a team like 11-14, and I was like, well, we can actually get to an elite level with the resources we have, because here's a team that's not too different from us that is doing things. And I was like, I remember talking to Seth and being like, we can get better. Like, we can totally reach this level of these teams. We're totally capable of it. We just need to kind of keep working at it.
Like, the things that held us back weren't, I wouldn't even say engineering design, it was consistency. We just made so many small errors that cost us matches. So many things, small things would just break because they weren't reinforced properly, or just slightly built a little too quickly, that if we had just given it a little more time, a little bit more thought, we would have been able to do it. With the resources that we had back then and the mentors we had, we could have done really well, but we didn't. But I can see that you guys got a lot better on that, a lot better than what we used to be.
I also think it comes with like experience, and we weren't prepared. And actually, well, we learned the lesson, we file that away and make sure that we don't make the same mistake. And with each year, you make sure you pass down that knowledge, you get better and better. I think that this year we weren't really, it was the first year we were captains. Like, we didn't know what to do.
And that's why you need like really good mentors who have been around for a while. You want the kids to be able to like build things and put in the creativity, but you want the mentors' oversight, looking at issues that we know that have plagued us season after season. These small issues that come with experience that the kids don't necessarily capture.
And yeah, go ahead.
No, good mentors do that. And now that you've had mentors for, I don't know how long it's been, 15 years or almost.
Some of them like 20.
Yeah. They have this wealth of knowledge now, and they've seen what has gone wrong and can tell the kids, maybe look at this again, maybe look at that again. You don't need mentors that could drive the whole process. You need mentors who give oversight.
Yeah, I think, just on that note, mentors for FRC alums are really valuable. Or, they're like, because they kind of been through it, especially as a kid, and it kind of sticks with you. Like, I feel like every mistake I made as a student is just ingrained in my mind so much more than, we still make lots of mistakes here and there, but, they don't stick with me as much. Every little thing I did wrong, like, it's in there on the surface.
So how do you impart that to the kids?
Well, it's mention it. Sometimes they don't really listen to it, which is okay. And then, then they'll make the mistake and hopefully learn from it. I try to give them the space where they can make the mistake and realize it before it does anything too bad, too harmful.
Yeah, I think that's what we do, like even in engineering now, with some of the younger people that we hire, is to build quickly, go through the mistakes, learn them yourself. Like, obviously I want like good products in the end, but I also need you to learn, right? Yeah. So I need you to build something, and even if I kind of know what's wrong, I need you to go through that learning experience. Because if I tell you, you're gonna listen to it, maybe you incorporate it, but it doesn't hit you as hard as if you go through the mistake yourself.
Yeah.
Because like when you design something, you have all these intuitions about it and assumptions about how you design, and then that's how you design quickly. You use your assumptions to do it. Unless you go through a mistake that forces you to change one of your assumptions, you're going to probably repeat it later on. So those lessons have to stick in your head.
Yeah, I think it's always, sometimes if I have like a story that pairs with it, I can kind of just give them that story and then they'll get it without having to make the mistake. It really depends on what it is. I'd like to say that I'm perfect, but it's, I'm still learning and making mistakes with, teaching kids. Sometimes I'll, go right for the end and be like, you can't do this, here's why. And, sometimes I need to do that because we have a match right now and this thing's going to go wrong and then it's going to be a disaster. But sometimes I can give the kids the space to make the mistake and I don't. I'm hopeful that I'm improving at it, but it can be tough,
Like, remember, like the first it is about competing, but it's also about building better engineers for the future.
Right.
Like, whole point at first is to learn about science and become engineers, and you need these opportunities to make the mistakes and go through them, because as you get older, go through other things, there's a higher expectation for you, so there's less chance of you to make the mistakes. And it's worse if you go through those experiences and you try to kind of fake it, and just like try to cover up your mistakes, go through it now. Like try to get as many mistakes out of the way as possible. Like you said, like break a robot as early as possible. Just keep going at it until all the things that would have broken off break off.
Mm-hmm. Yeah, absolutely. I thought it'd be cool to take a look at a match from 11-14 from that year, because that robot was so freaking awesome. Like that robot's still imitated to this day. This is from Waterloo, and actually with them is Team 2056. Do you remember Team 2056?
Remind me 2056.
So I believe their rookie year was 2007 or 2006. No, 2007. And
they were the Canadian team that just would always dominate. They've won pretty much every regional they've ever been to. Is that right?
That's right. So they paired with 11-14 always, pretty much, and would just win.
I forget. Are they connected?
Yeah, they were started, I believe, by an 11-14 mentor.
Okay.
So you know, to that point, they had
Winnovation.
No, it's not Winnovation. It's OP.
No.
They had similar robots a few years. Winnovation's 1625. They're still really good. But 2056 was like came out as a rookie at that point, hadn't lost a regional. They kept that streak alive. They actually still haven't lost a regional. They're in districts now. I don't know if you really know what those are.
Yeah. Have they lost a district?
They lost a district in 2017. That was the first time they ever lost a championship regulation event. It's pretty crazy.
Yeah, it's pretty crazy.
And here they are, just with an arm and some rollers. But this 11-14 robot, I think what made them so good, they were fast, right? So they were probably geared for like 14, 15 feet per second.
Mm-hmm.
But they never extended over the overpass. They just like went by it.
Mm-hmm.
So like they would shoot and just keep going.
There were many teams that had similar mechanisms. Like 395 in New York had a catapult, which kind of does the same thing. You're allowed to it helps you to launch the ball without extending over the overpass, and it allows you to shoot and drive at the same time. 11-14 just did it better.
Yeah, every detail was just executed better. You can see the time they put in. This was definitely not kind of like, out of the box, perfect robot, right?
Yeah.
They kept working at it. They definitely spent hours on hours on hours on those auto routines, and it showed.
I remember Seth Berg had posters of 11-14 from that year in his room.
I wouldn't be shocked if they're still there.
He was so enamored by it.
Yeah.
The interesting thing about that robot was that we used pneumatics to fire the ball. They actually used
surgical tubing.
They used tons of surgical tubing and kind of like a winch mechanism to fire it. Some other teams had winch mechanisms that would auto shoot if you wind it up, but they didn't. Now that I think about it, I never fully understood their mechanism and how they were able to do it so consistently.
So they had basically like a bow and arrow where the puncher is like the arrow, right? And there's surgical tubing back here. See if I can draw. So here's their puncher. Can you see that?
Let me. Okay, if I go to your screen.
Here. Can you see me?
Yeah, I can see you now.
Okay. Okay. So here's their puncher. Can you see that?
Yeah. Yep, I can see it pretty well.
And this is in the retracted position. So they had the surgical tubing, right? So this is retracted, and they had a strap connected to the top of the puncher, or it might have been the bottom. It doesn't really matter. And would go down to a winch that would turn, right? So it would retract it using the winch. It would turn and bring it back to this position. And the winch was on a shifting gearbox with two positions. One is, the retracting position, probably like a ratchet on or something, and the other is a neutral position with no gear in it. So when they would shift, it would go into the neutral, and this winch wouldn't hold it anymore. And so the surgical tubing would force the puncher forward and push the ball out. Then they would re-engage the non-neutral position, the driven position on the gearbox, and retract.
Oh, that's clever. I actually hadn't heard about the gearbox for the neutral position. I saw most teams had ratcheting winches, but then they would release the ratchet last second.
Yeah, or it'd be like I feel like a lot of teams probably use the cam mechanism.
Yeah, cam mechanism.
It would turn, and then at some point in the rotation, it would release it. So
yeah, correct.
It releases. But if you think about it, right, you're having the surgical tubing, so you have a set, spring constant, pretty close to set, and you're going a set distance. The shot should be fairly consistent.
Yeah, it's also much better to do that with the motor than it was with pneumatics. Creating energy with pneumatics is a lot less efficient than doing it with the electric motor. You have so many more inefficiencies with the compression of the gas and just inefficiencies in the compressor itself than you do with an electric motor.
Yeah, for sure. I mean, it actually was like a pretty simple robot.
Yeah, pretty simple but well made.
Yeah, really well made. And I think a lot of the best robots in FRC are like simple concept executed really well. Like they thought through, how can we have as few moving pieces on this as possible while maintaining consistency? What little thing can we do to up the consistency? And it's really rare that you go into worlds, to the championship, where you kind of know who the best team is by far, and then they win the championship. Like, I think that's only happened maybe 2-3 times in the history of first.
Oh, really? What was the other times?
So I think about it. So 11-14, 2008, 71 in 2002, the one that would grab all the goals.
Oh, yeah, okay, yeah. That was also way smaller back then, where there were only a couple of teams.
Yeah.
But yeah, they were definitely the one that was going to win.
Yeah. 254 in 2018.
Okay.
I'd say. Although I think they were beatable. But they went undefeated the whole season, 254 in 2018, like through 3 regionals and champs. No, it might have been 2 regionals, but still, the only team to ever do that. And 254 2014, I'd say also was at that level. But that's like, that's it. And there was
luck. I mean, luck plays a part of it.
Luck plays a part of it. But also just like luck is when preparation meets opportunity.
I really shouldn't say luck. I mean, consistency is something you learn in engineering. You learn that you have to build things consistently, and things have like life cycles, and you have to kind of incorporate that into your design. You're trying to build things that last just long enough with the resources you're given.
And I think, at this level of play, at the 11-14 level of play, you kind of have to be, you have to be consistent. You can't afford to break on the field, especially champs. You just can't. I'm happy to say, like, we're in that level now, our team is. And it's, for me, it's really hard because we have to balance that. We have to never break. But also every time we break, we learn a lot.
Yeah. So do you want?
So
do you want?
What do you do there? What do you do there? We go to a lot of off-season events, which are helpful because we can break there and learn a lot there. But that is kind of the trade-off of. It can be a trade-off of the winning.
Well, I mean, say you have a time when they just got right. Like you just had a good design, you just thought through, it was simple and worked consistently, and you won. You can't detract from that either. Like you can't say, like, sure, there was no lesson learned, but they just did a good job.
Yeah, I mean, we only got to compete at one competition this year, but we went undefeated. And the first match we actually didn't move, but other than that, we were really excellent.
Why?
I'm trying to remember. Yes, I didn't learn the lesson because I wasn't a student. I'm sure a student would know. Brianna, if you remember, she's watching right now. Brianna, if you remember, can you put it in the chat or unmute yourself and say it? I don't remember. We did not move in the first match, but other than that, we were really dominant.
Oh, okay.
And the kids just did a fantastic job. I didn't touch the robot once. I don't think there was really, I don't think any mentors worked on the robot. There were definitely mentors who like, this thing's broken, and they stood next to the kid and helped them through it. Like the climber had an issue at one point, and Tom helped the kids who were working on that. And then our mentor,
I think it's
making sure they were on task. But I wouldn't say that there were like a ton of lessons learned at the competition, but there were a ton of lessons learned in the lab.
Yeah. I remember one of the reasons why we moved was that one of our, so during the 2008 season, why we didn't move when the competition was the PWM cables came out. And this is something I had like been kind of adamant about, like, oh, we need to keep these, because back then there was no like holding mechanism to keep the PWMs in place. They just kind of were stuck by friction. And I thought that was never going to be good enough. I kept it didn't get done because, you know, it didn't seem like a big risk, but it was only after it fell out during a match that we finally agreed, like, it has to be stuck in, and we cannot take these risks again. And it's only after you lose a match that it stings more. You understand?
Yeah, you're not going to forget it then.
Yeah.
Yeah, like actually we had issues with PWM cables last year. And at one of our off-season events, a PWM cable came unplugged. And the way everything works now, there's a CAN chain. So it kind of like your signals in a series circuit. So if one thing unplugs, everything downstream of it won't have connectivity. Yeah, so we started after that. That happened in an off-season, but after that we started planning through, like started sitting down with the kids and talking about, okay, what is going to be the first thing in that chain? It probably should be the drivetrain, right? Started thinking through like what makes sense to have in that chain, and what are we going to do to prevent these things from unplugging. And the student in charge of electronics, she printed a bunch of retention clips for the PWM cables so they wouldn't come unplugged.
Yeah, that's what I was about to say. We had they made retention cables in 2008. They were these I think kind of like steel little clips that you can just put over the PWM cables. Some people, I know some teams kind of like hot glued them in as well to prevent them from falling out.
So the error was a CAN error that made us not able to move. It was I think it was what happened was, now I remember it, the PWM cable came out at the controller, which is called the Robo Rio. It came out at the controller, and those were really as secured as they can get. But our mistake was that we do a tug test. The students do a tug test on the wires to make sure everything's good. But they did the tug test after the systems check.
Oh, okay.
And the tug test must have gotten it loose. So after that, we're like, we should really do that test first. So
that's good. That's a good lesson learned.
Yeah, but you know, the thing you struggle with is like, you made that mistake, but how do you pass it down without letting him learn? I guess you got to play more matches, but you know, that's kind of, it's a constant battle.
You go 2 years later, and the student's going to be like, we're going to do their systems checks. Oh, then before the match, I just want to tug on all the cables just to make sure they're in. And you tell the student, no, you have to do that before. You always have to do that before. Why do you have to do that before? I know,
And then you tell the story.
I'm going to tug on it, and then if it comes loose, I'll put it back in. No problem. So either the student will accept your lesson, or they have to go through it.
Yeah. I think the story helps. Whenever I have a story that goes with it, I feel like it comes home.
Okay.
Yeah. Okay, so that's it for the competitions. I want to, I think we've been going for a while now. Almost 2 you can still stay on for a little bit?
Yeah, I can stay on. Yeah.
Well, it's 10 a.m. where you are, right?
Yeah, it's easy for me.
Yeah.
Oh yeah, I'm saying hi from Singapore, around the world.
So I thought it'd be cool to take a look at some of the interesting robots from that year and kind of just talk through some of them. This one I thought was really cool. Let's watch it through the video. They're really awesome. Nowadays, they're really awesome. But back then they weren't the best team. They were the only team with reveals though. Do you remember that?
I remember this video.
This is like the first, I think, reveal video, like full trailer video. This is the one I would work. Even though I know 111 had one.
If I remember correctly, they didn't actually do as well as we thought they would.
No, so I thought they were going to be like hurting, catapulting, swerve. They broke a lot.
Yeah, they broke a lot. They were like going too complicated and just having reliability issues. But if you look, you just look from the videos, they actually obviously were testing it a lot. This could have been a classic example of a robot designed well and works well.
Yeah, I just think, this is what a team, they're a national team. They're fantastic. Now, today, they're one of the best teams in the world. But until 2010, they always built work.
Back then, they were still considered one of the best teams.
Yeah, but they never had success at the championship level, and they rarely won competitions. And I think, it's a really interesting thing because nowadays swerve is a lot easier. They have, pods stuff, a lot of designs out there. We're looking at essentially building a swerve drive, and just kind of thinking of swerve is a bad idea. Look at these great teams that stop doing swerve now that
maybe you turn the YouTube video down a little bit.
What's that?
Maybe turn down the YouTube videos a little bit. It's hard to hear you.
Oh, okay. Sorry. Well, I turned it off now.
I remember Team 71, Team Hammond was the original swerve drive team. Has 694 ever built the swerve drive?
So we did it in 2004, and then we locked it in.
Yeah.
We locked it in place because it didn't work well. We haven't. There are a group of students who have been working on a design for one. There are also some COTS ones, commercial off-the-shelf ones that you can buy that are very good. But it's a debate the students are going to have because there are advantages to it, but it is a complication. And, when stuff hits the fan, I'm going to censor myself, when stuff hits the fan and you're in the middle of a elimination match and a module breaks, that's you're done. And that still happens to some of the best teams where a module breaks and you're done. But it does give you abilities, especially in auto, to do a little bit more because you can move differently. So it's a debate the kids are going to have. But definitely back then, it wasn't smart, in my opinion, for any team to do swerve because it really does take away from your other resources because 148 just built a swerve drive. They said that's all we're going to do, pretty much. You really can't. Yeah, and you really couldn't do. If you had a swerve drive, it was hard to make a good rest of the robot. Now that's a little bit different.
148, I think it was a little different. They built a swerve drive that worked amazingly well, worked consistently, and they were way underweight, and that was purposely done. They were focused on not building anything else because they want to keep the weight low.
Yeah, but I guess my point is, I don't think that they would have been able to build such a great drivetrain if they did other stuff with it. But because they focused in on that, they were able to do it really well, and they would be able to be one of the best robots in the world, even though they couldn't do anything with the balls other than knock them off. And they kind of made that conscious effort. I don't think they were like, this game's going to be decided by the lap box. They said, we're going to be the best in the world. How do we become the best in the world at this? Okay, let's build a drivetrain. But I think, nowadays it is really different because you can do a swerve drive a lot easier.
I guess what mechanism throughout the years were you the most proud of? This is a beautiful, heavily engineered artwork that you...
As a student or just looking at 694 in general?
694 over the years.
So our shooter this previous year was kind of insanely good. Because you have to shoot a ball, kind of similar to 2006.
Yeah, I saw the videos. I saw the competition.
Yeah, I mean that
That
thing's
you would always.
incredible. The student who designed it had been designing shooters kind of in his downtime for 2-3 years, and he really understood the physics of it, the stuff that's important about it, and it just all came together in this one mechanism. It's so consistent, and the software has a really good PID loop. The student who's working on the PID loop made this like automated PID tuning thing that he's tried to explain to me many times, and I don't understand it. But he understands it. And I think that people who know software better than me understand it. It's not that he doesn't explain it, it's that I don't understand it. And it's just, it's just boom, boom, right, same spot. And I think if the season kept going, they would have made it better and better. They really understood it at a high level, and they were working on that PID loop to make it better. They were working on the target to make it more accurate. They were working on the shooter to make it more accurate. I think in my years on the team, I've never seen anything quite like that. What about you? Your time on the team, what are you most impressed with?
So I was on the team for 4 years, from 2005 to the 2008 season. I was impressed by that 2007 drivetrain, the DeWalt drivetrain. That drivetrain was probably the best drivetrain we had built at that point. It was one of the most consistent, probably one of the most driven ones. Didn't break down. And it was great that it actually had shifting on it. That was it was pretty much that drivetrain that carried our team through the matches.
They were pretty much a box.
We were pretty much a box. Our arm did not work. I don't think we scored a single point with our arm during competition. And then we were a ramp bot, but our ramps were not that good. Our teammates had troubles driving up our ramps. So what we kind of excelled at was our drivetrain that could push people around and zip around very quickly.
Yeah, that was a good drivetrain. Nowadays, shifting gearboxes, you can buy them, commercial off the shelf. So we have shifting every year because you can just buy them.
Okay, and this seems like every year you guys have a very consistent drivetrain. Have you had any issues with them anymore?
After we play a lot of matches and we do a lot of practice, so sometimes the gears wear down. But we've gotten better at understanding that issue, and the kids have a practice of replacing them every so often. And I've actually done it so much that I can hear it now.
Okay.
So as I remember this off season, when the driver was driving the robot, and he's like, "This feels a little off," and I'm like, "Drive forward, drive back." And I'm like, "Here's the problem. I just heard it in the gearbox, and I described the problem." He took it apart and he found it, and I felt like a Jedi.
Oh, I remember one skill I had. It was kind of weird. Was that I could always tell quarter-inch bit. We use so many of them. I can just tell it by feel.
You can tell from a number 7. If I gave you a number 7 and a quarter-inch, you'd be able to tell the difference.
Yeah, I had it down. I just had it in the touch. But now we realize you don't drill out a quarter-inch hole with a quarter-inch drill bit. That's wrong. You drill it out with the appropriate size clearance hole, a little bit bigger. And that's why we always had issues trying to put quarter-inch bolts through our holes.
Well, you just do this. You just drill it, and then you wiggle your hand a bit, and then it's big enough.
Yeah. That's how you damage all your quarter-inch bits. That's why you had a box of them.
We still do that.
Still use
so what should we use? Look
it up. Let's look at machine clearance table.
Okay.
It tells you what size to use if you want close tolerance or large tolerance. For the most part, you'll want close tolerance.
Okay. Brianna, who's listening, she's our new president of engineering. You need to look into that. She's the one labeled Leon on there.
Okay.
Okay. So I want to show some good robots from that year. I think there are 2 really important robots from that year in this match from New Hampshire. Team 58 was, in my opinion, the best under the overpass robot. They just pick up the ball and roll it out. And Team 121, who's on the Red Alliance, had this design. I think they released it on Chief Delphi, or they spread it around a lot because a lot of teams copied this design. It was really simple. They have just a roller and an arm. That's it. They're over here on the far end. Let's see if we can get it better. This is 58. They just have a roller and that's it. So 121 right here. They just have an arm and a roller on the end of it. And this is actually the same design that Saunders ended up going with.
Okay.
So here's 58. They pick up the ball really easy, and they just they're scoring on the other side. They let go of it, and it's kind of cool because it's almost like they never lost possession of it.
Yeah, I remember that. That was a very smooth operating robot.
Yeah,
and that's what you wanted. You wanted to be able to like manipulate your ball without having to really stop.
Right.
Way to track down.
Right. The only issue is, at high levels of play, there wasn't really space for an under the overpass robot.
Yeah.
But here's 121 scoring, by the way.
Oh, I see. Okay.
I just remember being really enamored with the 58 robot because it was so clean and consistent at this. That they were, a captain of a finalist alliance at one of the best events back then. The Grand State, this was week 1. It was always an event where it's like some of the best teams in New England competed.
When do you feel like rollers became really big in 694?
I'd say after this year.
Yeah, I think you were. I remember you had talked about trying to put rollers at the end of our manipulator to try to suck in the ball, because that was like a point where we would waste a couple of seconds every lap trying to get the ball. If we had sucked it in, we would have done it better.
Yeah, because I started, as I was watching all these matches from around the world, I started realizing that all the best robots grab the ball with rollers. And I started thinking back to other years, and rollers are pretty much always the answer. Even when you kind of don't think they are, they are.
So how do you feel about that though? Like now there's this kind of like consensus design, and a lot of teams go towards rollers.
I think that's. Oh, what just happened? You still there?
Yeah, I'm still here. I
don't know where you went. Let me stop sharing for a second, and let me start sharing again. I think that rollers are. Here we go. I can't see you for some reason. Here we go. Much better. I clicked on something. I think rollers are almost always the answer. Still true. Still the case. But it's about the details of it. Have you geared it for the correct speed? When do they need to be rollers that open and close? Because sometimes you want rollers for pickup, but you don't necessarily want rollers for scoring.
Okay.
Sometimes you want to place. So you want rollers that grabs. When do you want rollers on a wrist? Right, to come out, to pick up better. So these are the details that matter more. But in general,
but it's always wrist with rollers, pincer with rollers,
right?
Rollers with mini rollers. Yeah.
So you always have to start with rollers. If you're not doing rollers, there better be a really good reason why. Even this year, there was like a bar to hang on, but it swings, and you want to get partners on it. Yeah. You want it to be balanced. So what do teams do? They have a climber with a roller on it, so you can roll back and forth on the bar.
Oh, really?
Yeah. We actually were looking at doing something like that, but had a lot of trouble getting it onto our hook.
Okay.
And our hook worked really well. Actually, so the team that really, this is the team that really made it click for me that rollers are great. I remember watching just some California event. This is actually from Champs, but Team 100, this orange robot right here, they just had rollers and a wrist on a lift. And it was just like so simple, and it worked so well, and they picked up the ball so easily. It's like, oh, that's so good.
I mean, there were a lot of robots that year that had rollers, and half of them weren't very good. So yeah, I mean, just having rollers isn't enough. You have to execute well.
Exactly. But you see how easily they pick up that ball. Just drive right. Yeah. And I would even argue that those rollers are not geared fast enough. They need to be faster, but still work great. Their partner in this match is Team 16, who was really great that year. You kind of see them zipping here, and it's hard to tell, but they're huge. Do you remember what they did, Steven, to make themselves be able to be bigger than everyone else?
Team 16?
Yeah, Bomb Squad. They're right here.
They started from vertical position and they dropped down. Yeah.
So back then, you can't do this anymore, but back then, your frame perimeter was just defined by like your starting position, how you started. So they start against the wall. So their robot was absurdly long, and they would just drive and flop everything out. And I remember walking down the aisle at Champs and seeing their robot. I was like, holy shit, that robot's huge. Whatever.
That was the only time. No.
71 did it in 2002.
Yeah. That's how they were also gigantic.
Yeah.
And they were so big, they pretty much took up half the field, which is crazy. It's like, how you can't do that anymore.
Yeah,
so but it's such a clever idea.
That's always one of the things that I feel like you should look for in the game manual is there a way you can make yourself bigger than teams might realize? Is there something you can do like that?
I remember there was this a couple of robots did this where they had like they had a crane almost, and they had like a circular movement arm. So they would just sit by the corner near the overpass, grab the ball, and then instead of like driving through the track, they would just bring the ball around the track and then score.
Yeah. So that was 190.
Yeah.
And they came out with that robot. So they had a crane, and they just basically stood at the overpass and tried to do that. And the next week, first said that's legal. So that's like messed up because their whole season like bet on that.
Yeah, I remember there was another robot that was planning to do the laps by climbing over the barrier and just like kind of like a monkey just going round. The mechanism in 190 was pretty cool because they had a crane. They had to rotate like 360 degrees continuously. Usually that's an issue because your wires would tend to twist. So what they had in their turret system was these bands of copper that acted as electrical contact. And they had like armatures that would just contact the wires. So this way it could just continuously rotate without twisting wires. I thought that was clever.
Yeah, I mean, 190, they were definitely always a creative team. I'd say there are a lot of rules in first that are like year to year that exist right today because of stuff 190 tried to do. That's them with the crane looking thing.
I think there's a place for that. That's kind of part of why they want kids to be creative, like try to think of like cool ways to do things. Yeah. But they also don't want to destroy the competition and ruin the season for everyone else. So at some point you do kind of have to ban these crazy mechanisms.
Yeah.
They even use a vacuum.
Yeah, so we actually, I don't know, have you seen our 2019 robot?
Yeah.
Yeah, so that had a suction cup. That's the one with the suction cup.
Oh, where it went down and then you lifted yourself up, right?
Yeah, I mean, that was crazy. That was freaking insane.
I can't believe you guys did that.
Yeah. The entire season, I was like, oh my God, this is going to work. This is going to work. Trying to be encouraging to like have the kids do it, but meanwhile, super stressed that it wasn't going to work. And try to help as much as I can. But it worked really well. It worked great. There's still room for that kind of creativity.
Imagine if you just told them, this is a bad idea, we're not doing it, then they wouldn't have that chance to kind of explore.
Sure.
And you wouldn't have built that actual mechanism that worked fantastic.
Yeah. Well, I did one better. I said, this might not work, but let's gamble. Sometimes if this works, we're going to be really good. So let's gamble. That was super fun. It was also super stressful. Okay, so that's it for the robots. Were there any of the robots you remember that you wanted me to show?
From that season, what was? I remember there was a bunch of catapult robots that should have worked better than they did. What was Robot Chicken's robot like?
Thunder Chicken. That robot was crazy. They had it was just an arm on a lift. By the way, Thunder Chickens were world champs last year. They're still good. their robots had like these. Let me just show it.
Sorry, did you show a video of 148, like their teaser video?
I did.
Of the drivetrain?
did.
Okay.
That's the one I just tried to play. This was actually 968's in this match. This is back when 968 and 254 used to build the same robot.
Oh yeah.
254 is like the best team in the world nowadays, or strongest competition-wise anyway. So here's 217 in green. This is super pixelated.
Yeah, it's a bad video.
Yeah.
Okay.
See if I can find a different video that isn't as pixelated. But 217 would always do these kind of really out-of-the-box ideas.
That would work.
That would work really well.
Yeah.
Back then, I think you had a lot more room to break than you do today.
What do you mean?
Like you could be broken in a match and still totally dominate champs.
Oh, but now the competition is so much stiffer.
Yeah, everyone's just so good. You know, everyone has those years of lessons. They're a lot more. Everyone's had years of recruiting mentors. People have better machines, more money. First is, you know, there's more of an emphasis on first. More students are involved.
Which is good. It's growing.
It's great. It's great. But that makes it harder, you know, which is good. You know, it's not worth doing if it's easy.
Yeah. I still wish first was even bigger, to be honest. Like when I'm hiring for engineers, I would love to see more mechanical engineers, someone who's had like practical experience, some design experience, creative, like rapid prototyping experience. And that's still lacking even now.
Yeah, I feel like, you know, the first robotics competition, if you are really involved in it, it sets you up for a lot of life.
Yeah, I mean,
regardless really of what you do.
A lot of engineers who were in first look for other first engineers because they know the experience you've gone through, and it's a lot of experience. When you compete for 4 years, studying robots, going through thousands of hours of build seasons, that shows.
Yeah, and I think having to work on a project like this with people, like having to manage people, having to, you know, talk to a mentor was really kind of like, in a way, like a boss that you have to, like, this is an older person that you respect, and you're gonna have to hold your own. Like that teaches kids how to handle those real world situations.
Yeah.
Are there any other robots you wanted to show?
I'm just looking at Thunder Chickens. It's so fun. It's just a funny robot.
It's absurd.
But they were the second best team in the world with that design. That's incredible.
Yeah.
I want to see more designs like that. I want to see people being like super creative but executing.
Yeah. So there's a lot of like open source stuff where teams are just posting their designs, which is good because it helps younger teams so they can just use that design and use stuff from it. But you know, the trade-off is, you know, that creativity piece where it's like you're just copying a design.
Yeah, it's a balance. Engineering is about using previous experiences and what other people learn to further yourself. You can't say that if you use a design from the past that it is purely copying. That's part of engineering, is just learning from that.
Yeah, I think, you know, steal from the best, invent the rest. There's that inventing part. You know, you might steal a thing, but you have to fully understand it to execute it right. So you study it, learn from it, you improve it. You don't just leave it as is, because it'll at best be as good as that thing.
Yeah, you know what? As long as you understand how they build it, understand the idea of it, that's totally fine. That's still learning. I love that.
Yeah. And you can make it better.
Yeah.
There's always room for improvement. In the real world, yes, there are new inventions, right? There's new industry. There's what is it called when the disruptors, right? In everything. But there's also, take a thing, improve it. Take a thing, improve it. That company did this. I'm gonna look at that.
The biggest companies are the ones that can just make a product consistently, make a good quality product. It's great to have disruptors, but it's more important to have consistency.
Mm-hmm. And even if you are a disruptor, there's still going to be competition. There's still going to be stuff to learn from.
Mm-hmm. Mm-hmm.
Okay, so that's it I had about the 2008 season. I think a lot of our students would be really interested to know kind of about your college and career.
Oh yeah.
So why don't you talk about where you went to college, what you studied?
Yeah. So when I was in high school, I still wasn't sure where I wanted to go or what I wanted to be. I thought maybe I'll do electrical engineering, maybe aerospace. But I still knew that I kind of wanted to be an engineer, and mechanical was the most obvious one. But I wanted to explore other things. So I actually worked at Tom Ferguson's company for one summer as an intern, trying to learn aerospace engineering. I feel like that wasn't for me. So during high school, I went through all the 5 Tech, 10 Tech classes. I did all physics A, physics C, did the statics dynamics class, did pretty much every engineering type class Stuyvesant had to offer. And then I went to MIT. At MIT, I actually had a bigger focus on sustainability, trying to learn about life cycle analysis of different products, how we can reduce the environmental impact we have. I worked on a couple projects related to, one year I went to India, worked on hybrid series vehicles for the Indian market, tried to get like gasoline cars off the road, tried to help with the environment. Second year, I worked with this electric vehicle team, trying to design electric cars for fast recharge. Back in the day, that was like a huge thing. Because there were a couple of electric cars, but they were all charging, like they would do trickle charge, which would take hours and hours to do. We were trying to design the car that could charge in 7 minutes. So it involved looking at batteries, looked at utilities, how can the infrastructure kind of support that? Did that for a little bit. The thing that I'm doing right now is actually desalination work. Where I wanted to go was kind of looking at the infrastructure utilities side of the world. I think there's a lot of communities that could be better if they had the proper resources. And proper resources comes with like utilities, like energy. If you have energy in a region, they can grow. You also need water. If you don't have water in a region, you can't build a lasting society there. So right now I'm doing desalination work. After my senior year, I got involved in this water lab where they did research on different desalination techniques involving like thermal desalination, membrane desalination, some kind of pretreatment technologies. And then I was part of this team that started a company called Gradient that does desalination work. It's evolved to grow into more of water technology. So now we are a technology provider. We do technology in-house, but we also work with other partners to bring technology in. So this way we can design for a treatment system from start to end. Sometimes the treatment system involves our proprietary technologies that we think are better than what's in the industry. And sometimes we do what's on the market because there's no point in us trying to put our own product on the market that isn't better than what other competitors have. We have only so many resources. We can only tackle so many different technologies that we want to just try to provide the best solution for people. So now I'm working in Singapore. Our company opened another office here, another research center, which I'm heading. And we're doing more technology research on the thermal desalination side and RO membranes. We've come out with a new product called CFRO, which is a type of membrane desalination technique that allows us to concentrate water to the saturation point, which has never been done before in the world. We commercialized it last year, and we're hoping to bring it, get it into the market and get it around the world within. We had the goal of doing it in 2020, but then everything kind of slowed down.
Yeah, nothing happened.
We had 3 pilot plants running at the same time, and then we just had to pull out all our workers, all our operators from those plants, and now they're kind of idling, which is unfortunate for the technology, but we understand. So we're gonna, as soon as this whole lockdown ends, we're gonna go right back to those plants, show off the technology, show that it works, and then keep going. I think everything that I've been able to accomplish at this job has been attributed to first being able to work with people, work on tight deadlines, trying to build things that sometimes aren't perfect. You going through the mistakes, build something first, get it out, see how people react to it, and then build something else and just keep improving. There's a lot of humility to doing that. You have to be willing to take criticism. You have to be willing to understand that it won't work out correct the first time, and you need to make it better. There's always room for improvement there.
Yeah, I think, just like jumping off that point, I think one of the biggest lessons I learned first is that it's not going to work the first time. It's not going to be perfect the first time, for sure. Like, it might work. It depends on your definition of work, right? But it's not going to be perfect. It's not going to be the final product right away. And kind of making the first one is just part of the process. You kind of got to keep improving on whatever it is in life. And I think, some kids learn that right away. Some kids, it takes a little bit of time, but sooner or later, everyone learns that.
Yeah, it is really exciting when something works for the first time. I remember when we built that first plant in Midland, Texas, and we were desalinating industrial oil and gas water. And then we had this huge, huge tank. It was maybe 20 feet wide, 20 feet tall, being filled up with fresh water being produced from our plant. And before then, we didn't have prototypes that were that big. We always get like vials of fresh water. And then once we had an actual plant, our very first plant producing fresh water, we could just tell everyone this thing's actually working. And it felt great. Sure, there were a lot of things that could be better. It wasn't working as consistently as we wanted. Energy consumption was a little bit higher than we wanted, but those are things we can get better at.
Right. Okay. Another question for you. So, what advice would you give to our STY students? Like, a lot of the kids watching this, there's going to be some seniors, but there's going to be a lot of, I think, more juniors that are going to be watching this.
Take ownership of something. Take initiative in something. People do their best to try to give you training, try to teach you, but it doesn't always happen. And even in the real world, when you go into an internship, sure, people are going to try to teach you things, but it helps on like the management level if you can take ownership of something. You take your own initiative, get yourself motivated, and just kind of provide work for it. So if you're starting out on the first team, try to get on a project, try to build a mechanism. Don't wait for someone to tell you if this is right or wrong. Like, say that you're building a shooter mechanism, and there's like kind of an accepted design. Well, if you think there's something better, try it out. If you really believe that I have this idea, it's a great idea, Mr. Blay thinks it's terrible,
Ignore him.
Try it out. You build it and then show it to him. If it works, great. You've accomplished something. You made the robot better. You've gained confidence in yourself. You learned something. And then Mr. Blay also learned something, that this idea can work. So don't shy away from that. A lot of people will tell you that maybe an idea is wrong based on their own experiences. So from all my experiences, I've built these assumptions on how to design, and I come up with this idea that I think is the best. But it's important that you've grown up differently. You have different experiences. You have different assumptions. You think about problems differently. So let's see what you get from that.
Yeah, I remember, kind of going off that 2008, we had some people had this idea of building a catapult, and some other people dismissed that as that's impossible.
Mm-hmm.
Right? And we kind of just moved on from it.
Yeah, but like catapults did work that year.
They worked great. Yeah.
Yeah.
And I think the kids, I wasn't one of the kids who was like, we should build a catapult, or I wasn't one of the kids who had the idea for it or anything. But those kids who had that thought, could have gone off and tried something and prototyped it better.
Yeah, I remember it was Andrew Mandelbaum who was like leading that design effort, and he thought catapults should work, and then he built a prototype. He tested it. It didn't work as well as it could have, and then he kind of dropped it. But if he had tried it again, if he had tried a second prototype, if he put a little bit more work into it, effort into it, it could have worked. It could have been amazing. But you got like a little discouraged from it. And engineering and research can be very discouraging because there's a lot of lessons to be learned, a lot of faults that happen, but you have to kind of push through that. Just take it in heart, learn from it, get better. Always try to prove yourself.
And my last question for you, do you think, are there any other lessons that you learned on the team, technical or otherwise, that you would want the kids to know about? Can be related to leadership or
I do think that I do think engineering was very good. It was great to learn engineering, but it's really interacting with people that was more important. When you have such a big team and learning how to work together was more important. First of all, how do you lead a team? Second of all, how do you get people motivated? How do you get people working? In my personal opinion, I thought the best way to lead the team was to make sure everyone was working, doing something. This way you're actively engaged in something, even if it's maybe on the smaller side. But as long as you're engaged and then something else comes up, then you can quickly shift to that. But if you're not engaged and an opportunity comes up, then you have kind of this inertia that you have to overcome to like get part of it. So if you're kind of, I don't know, people say like a happy hands makes a happy mind,
What is that?
Meaning if you're like always doing something with your hands and doing things, then your mind is happy and then you want to keep moving towards that. I think it was also important to learn how to work with people, how you have like different ideas and how to encourage each other. You guys working on a team and things get tough and you have to encourage each other to keep getting better. I thought that was important.
Okay. If anyone in the chat has any questions, you should post them now because we're wrapping up.
Oh, I think one thing that really helped me was kind of like public speaking. I was very, very nervous on the team whenever we had to talk to sponsors, whenever we talked to reporters, did interviews, kind of just talking to anyone that was an adult. I'm still not very good at it, but being on the team helped me. Sure, you're going to make mistakes talking. And honestly, people understand that you're kind of starting out. You have all these nerves. You just have to keep practicing, practice. And eventually it gets easier and easier to talk. You're kind of like hesitant to talk because you have all these ideas, but you can't put it into words. So if you talk about it a little bit at a time, you start to formulate sentences that you can kind of repeat. That will make it easier for you to talk later. And then you can just like keep building upon that. You have essentially kind of like building your vocabulary of talking ability, and you get better at it.
Yeah. Okay. Cool. All right. Thanks for doing this, Steven. I really appreciate it. This was 2.5 hours. So.
Thanks, Joe Blay. Thanks for sitting with me for 2.5 hours.
Oh, I'm happy to do it. We have to do our call soon. I don't know. We're doing it this weekend. We got to do that.
Okay. Yeah.
Okay.
Yeah, even after all these years, we still hang out with each other.
Yeah. That's actually, that's the craziest thing about looking at those videos from 2008 is how many of us are still friends and still hang out.
Yeah. Like we were just at each other's weddings not that long ago. Joe Blay was going to be one of my groomsmen for my wedding this year, but fortunately that's going to be pushed out to next year. So even when I moved to Boston, every year I came back to New York and I would have this kind of like Friendsgiving with all the people in robotics or people associated with robotics. Some of my best friends are still from robotics, even after all this time. And we still do weekly calls. We just chat with each other. It's not about robotics anymore. It's just about our lives. But yeah.
I think there are, as I talk to some of the younger alumni, I think those groups exist with them too. I don't think any of them are at our level, but I'm hopeful that a lot of these guys stick together.
All the people I consider my closest friends on the robotics team, I still hang out with them to this day.
Yeah.
I don't physically get to visit them as much anymore because I'm on a different continent, but still chat with them all the time. And if we can hang out, we will hang out.
Yeah, I mean, you flew in for the weddings and also our trip to California last year.
Yeah, that was pretty fun.
Yeah. Okay. So I'll let you go. Thanks for tuning in. I'll have another episode for you guys next week. Hopefully Seth Berg will be with me to talk about 2009.
All right.
I'm stopping.
Maybe I'll join